for the emergency?
In Glen Street in San Bruno. There's a huge fire. Something exploded.
Okay, where in San Bruno?
That was September 9th, 2010. Residents of San Bruno, California were just sitting down for dinner when the 30-inch natural gas pipeline buried under the street in front of their homes failed. Releasing enough force to register 1.1 on the Richter scale, the explosion was massive. Within minutes, 8 people were killed and 38 were injured. Around the explosion point, 38 homes were burned to the ground and another 70 were left severely damaged. Final cost, $1.6 billion in damages, and 4 years later, the pipeline operator was fined $1.4 billion by the state regulator. So take a minute to look at this map. That's the US oil and gas infrastructure. There are more than 2.8 million miles of pipelines in the United States transmitting hazardous liquids and natural gas, and more than 50% of those pipelines are beyond their original service life. And today, with population growth, more than 12.5 million homes in the US now are located, like those homes in San Bruno, within the impact radius of a potential pipeline failure. The industry is spending almost $8 billion a year battling corrosion. And how are they doing? Not so good. Right now, the United States Pipeline and Hazardous Safety Materials Administration says that pipeline corrosion is still the most prevalent cause of pipeline spills and failures. So how do we detect and mitigate corrosion? The detection and mitigation process is a labor-intensive and multi-step process. And it begins with an inline inspection tool, more commonly known in the industry as a pig. The pig is inserted into the pipeline and pushed along by the product in the pipeline itself. When the run is completed, the pig is returned to the pig vendor, and some 6 months later, an Excel spreadsheet shows up on the pipeline operator's doorstep. His immediate function is to look for critical defects in the pipeline, so he'll begin to pare that spreadsheet down. Now, these spreadsheets are anywhere from 5,000, 10,000, to the biggest one I've ever worked on is 1.3 million records of defects in an 80-mile pipeline. Ultimately, they'll launch the crews out and they'll go and make an excavation. So after spending $20,000 or $30,000, it's really embarrassing to find out that you're at the wrong spot. It's even more embarrassing to find out that another crew put a sleeve on that 3 years ago. But ultimately, the field technician's responsibility is to take that now much lower fidelity data set from the pipeline engineer, mask it out onto the pipe, and determine whether those two things align with what he's created in this artistic work using his Sharpie. So what happens? Pipeline engineers today spend a lot of time looking at multiple spreadsheets, trying to pick up patterns. It's pretty hard for the human to do that. Now, I notice a lot of you have not been making notes, so while I was back there, I jotted some down for you. That on-pipe data is about 3 gigabytes of data a month for an average-sized pipeline company between 10 and 15,000 miles. The ILI data, or the PIG data, is an additional 30 gigabytes of data every month. And operational data from their SCADA systems, which are the control systems which do pressure, temperature, and that kind of stuff, is an additional 228 gigabytes of data. There's a lot of data. But the strange thing is that in corrosion, we, like the tip of the iceberg, we're only using 0.3% of that data to determine where the pipeline's going to fail. So here's the opportunity. Using machine learning, we need to take labor-intensive processes and convert them into automatic processes, keeping the engineer in the loop, adding value to the process. We need to take these high-cost processes that have a low-certainty outcome and convert them into low-cost processes that have a high-confidence outcome. And we need to take the process of reducing data fidelity, adding all of the data into the mix so that we can create a predictive analytics model. We're OneBridge Solutions, and we predict pipeline failures, saving lives and protecting the environment. And this is how we see pipelines as smart infrastructure, using machine learning to ingest the over 30 different pipeline vendor data sets from ILI and PIG vendors, whose data is consistently inconsistent. We're able to free up an inordinate amount of time of engineers in the field today. That's where they spend most of their time, is trying to match data. Using machine learning to use 100% of the data that's collected, we're now able to visualize in a graphic format that immediately shows patterns to pipeline engineers, allowing them to work on stuff like corrosion modeling and risk analysis. And we're adding the Xbox experience to pipelines. We have embraced the HoloLens. Using the HoloLens, we can move the pipeline engineer from his desk into the ditch with the technician in a data-rich, immersive environment that's interactive and real time. So based on this foundation of smart infrastructure, we see accessing other data sets in the industry, and that's about a $1.4 billion income potential. I've spent 24 years digging holes on pipelines, and with my partner, Brendan Taylor, we've put together a well-rounded team of experts who can scale rapidly. At the beginning of this sprint, we put together an advisory board, and that advisory board is made up of pipeline regulatory personnel, pipeline operating personnel, and pipeline service company personnel to help us validate the vision and grow the company forward. So in May this year, we got to the point where we were sufficiently confident with our process that we thought we would engage a couple of pipeline companies. We've contacted 2 pipeline companies for our Tier 1 program. Those 2 companies are going to bring about 25,000 miles of pipe into our system, about $1.5 million in revenue for us annually. And these 2 pipeline companies are both experts in the industry in terms of knowledge matter and household names. I can't tell you their names. Somebody else did that tonight earlier. but we're on the edge of the contracts with those guys. And based on that success, we've engaged Microsoft's oil and gas sales teams, and we're now approaching 4 additional companies who will bring us more pipe, 23,000 miles specifically. And based on the validation of our algorithms using the data that they provide against their on-pipe data, we think that we can hit GA by October of this year. So what we're looking for tonight is strategic partners who can help us disrupt the industry and grow our company. We're OneBridge Solutions, and we predict pipeline failures. Thank you.